Antibiotics, friend or foe? I'd just like to mention that I got most of my research from Dr. Moore's lecture in microbiology last fall and the Mayo Clinic website. So, bacteria have always threatened humankind. 500 years ago, this bacteria, its scientific name Yersinia pestis, killed a large portion of the world's population. It's better known as the plague, and it's estimated that it killed between 1/3 and 1/2 of Europe's population during the Middle Ages. Here's a graph showing that. And it killed so many people because they didn't know what bacteria was at the time, and they didn't know how to treat it. Until 1928, when Alexander Fleming discovered penicillin. And since then, doctors have been prescribing penicillin and other antibiotics for lots of conditions, and basically giving out like candy. And this is how superbugs have been born. And this is important to me because I'm planning on working in healthcare, and it seems like this is an overlooked problem that has a good possibility of becoming a real issue for society in the near future. And it's an ethical concern because it's up to the doctors to prescribe these medications, and if it's not controlled, it could lead to another pandemic just like the plague. So today I'm going to tell you about antibiotic resistance by explaining what it is, what causes it, and how to stop it. So, antibiotic resistance, what is it? The FDA defines it as the ability of a microorganism to withstand the effects of a particular antibiotic. So to first understand this, we need to understand this picture here, which is basically natural selection or evolution. And so we start here with a genetically diverse group of bacteria, and each has their own genes, their own DNA. And when we introduce an antibiotic, our goal is to kill all the bacteria, but some have a unique gene that allows them to withstand the bacteria, or to withstand the antibiotic. And it'll survive and multiply, as you can see right here. And that's basically the superbugs. And although these unique genes are rare, there's lots of bacteria out there. This pencil has over 1 million bacteria on it, and each one of you has probably over 1 trillion bacteria on you. So when they multiply and reproduce, they pass on these antibiotic genes to their children. So each offspring has the antibiotic resistance. And if you think that's bad, not only can they pass down these genes to their children, they can give it to other bacteria in a process known as conjugation, which the bacteria makes a tube here where it delivers its antibiotic genes to other bacteria, neighboring bacteria. And then an example of this is MRSA, or methicillin-resistant Staphylococcus aureus. And Staphylococcus aureus is the most common bacteria found on the skin, and it's also the bacteria that causes toxic shock syndrome, and it's also the bacteria that causes staph infections, hence the staph in its name. And according to the Mayo Clinic, about 1,000 deaths per year happen because of MRSA due to hospital infections. And basically how MRSA works is, as the cell wall, you can see it on here very well, but it protects it, and the antibiotic breaks down that cell wall, and this bacteria has a gene that changes the cell wall so the antibiotic doesn't break it down. It allows it to survive and reproduce. So why is this bad? If you're infected with one of these bacteria, you'll remain sick longer, because we have less medications to treat these kinds of bacteria, which will cause you to stay in the hospital longer and spend more money on your hospital stay. And because there's less meds, we have to use more specific drugs that are usually more expensive, less effective, and more toxic than the normal meds we would use. And the overall effect of this is higher mortality rates and more deaths than would normally occur from bacteria. So what causes this problem? Misinformed patients demanding prescriptions every time they go to the doctor's office. It's become an expectation that when you go to the doctor's office that you should get some kind of medication for your sickness, even if you don't need it. And an unethical physician will prescribe for these people. One example of this is this picture right here, rhinovirus, otherwise known as the common cold. And antibiotics have absolutely no effect on viruses. So say you go into the doctor and you demand medication because you have a cold. You have runny nose and a cough or something. You might demand this medication. Shame on you, because this is a problem, and you don't want to do that. Let's see. And another cause of this is excessively washing your hands. Although washing your hands is good, it kills all the bacteria on your hands and keeps you healthy. But when you wash your hands 10, 15, 20 times a day, you get the same effect as antibiotic. And you might think twice if you get something like this on your hand. Dermatitis caused by antibiotic-resistant bacterial infection. So, one way to prevent this from happening, the Mayo Clinic has a few tips to stop this. One, finish your course of medication until it's gone, even if you feel better, because some of the bacteria can survive and reinfect you. And try not to skip doses. Throw away expired meds, and don't save those meds for the next time you get sick, because the bacterial infection you may have had before might not be the same bacteria, and the same antibiotic might not work for that. And don't take someone else's medications either, because the same reason, they might not have the same infection as you. But there is hope. There's new and improved vaccines being developed in universities throughout the country, even here at the University of Minnesota, that we can use instead of antibiotics to help reduce the use of antibiotics. And right here is a bacterial cell being attacked by viruses, bacteriophages. And one of the things being developed right now is something called phage therapy, where you go into the doctor's office, you drink a cocktail of these viruses, and hopefully get better. But one of the problems with this is that bacteria can actually form a resistance to these viruses. So until some kind of miracle drug is made, we'll continue the biological arms race where bacteria will develop resistances to our drugs, and we'll continue to develop drugs for these resistances.